Hey everyone, I hope all of you guys are doing good and staying safe. So in this video, I would like to continue with my previous video on networking 101 to give you a lot of insights in regards to what subnetting is all about and why do we need that. So subnetting is all about taking a very big network and breaking it down into smaller networks. So you would possibly have seen this when you were studying in college that you had a separate department for CSE, you had a separate department lab for ECE and for EEE and E&I and so on. So if you have so many different labs, you get a very big network address, and then you subnet it into smaller networks for each and every lab, depending upon how many resources you're going to have allocated in those respective labs. So in one single sentence, you get a very big address for your network, and then you break it down into smaller subnetworks. And the process of doing that is called as subnetting. So we have a classic example over here with this particular example where you have the network address to be 10.0.0.0/16 in decimal notation. /16 over here is called as the subnet mask. And the subnet masks allow us to determine what is your network portion and what is your host portion. And over here, you can see that an IP address is in IPv4 notation is 4 octets of 8 bits each. And this can be represented in 8 bits. This can be represented in 8 bits, but we are doing the decimal notation of this. So over here, the subnet mask out of an IPv4 address that on the total has 32 bits, whereas an IPv6 address has 128 bits. The IPv4 address of 32 bits, out of which 16 bits are fixed for the network portion, which means the first 2 octets are fixed, whereas the last 2 octets can change. So over here in this particular example, you can go all the way from 10.0.0.0 to 10.0.255.255, where the last 2 octets, which is allocated for the host portion, can go all the way from 0 to 255. So you can see over here on the whole, an IPv4 address is of 32 bits minus 16 bits, which is fixed for the network portion, which means you still have 16 bits, which means on the whole, on the total, you can have a combination of zeros and ones in binary. So which is 2 power 16 in terms of possibilities, which is 65,536 in terms of total IP addresses that you can have for this particular network. But then in terms of traditional networking terms, you have two IP addresses that are reserved, which we saw in the previous class, which is the network address and the broadcast address, which is the first IP and the last IP, which means the total number of hosts that can be allocated out of this particular big network is 65,536 minus 2, which is 65,534, where the first IP and the last IP are reserved. So if this is true for this particular example of a very big network, let's say, for example, we subnet this network into smaller networks. Let's say, for example, I'm subnetting this /16 into a /24 network, which means in a /24 network, the first 3 octets are being fixed for the network portion and the last octet can change, which means in this particular subnetwork, you can go all the way from 10.0.0.0 to 10.0.0.255. You can only have a 256 total number of IP addresses, out of which in traditional networking terms, 2 IP addresses are reserved, which means you can only have 254 that you can allocate to your hosts. So you subnet your networks depending upon how many hosts you would like to have in each and every network, right? So similar to that, the next subnetwork would be 10.0.1.0, which will go from 10.0.1.0 to 10.0.1.255. The third network would be 10.0.2.0/24, where again the first 3 octets are fixed and the last octet changes. So you can go from 10.0.2.0 to 10.0.2.255. Now you can see a pattern that is being formed. And the next network after this would be 10.0.3.0/24, where you get 10.0.3.0 and 10.0.3.255. So you always have a buffer of some of the extra subnets that you can create out of a very big network. So this big network has total number of 65,536, which you are subnetting into equal number of 256 IP addresses that you can have in each and every subnet, out of which in traditional networking terms, the first IP and the last IP is reserved, which means you have a total number of 254 that you can allocate. But when it comes to AWS, the number of IP addresses that they reserve is 5 IP addresses. So you reserve the first IP for the network, second for the router, third one for the DHCP server, fourth one is just reserved, and the last one is for broadcast. So on the whole, out of 256 in a particular subnetwork of /24, you can only have 251 that you can allocate for your host because 5 IPs are reserved by AWS. But in traditional networking architecture, the first IP and the last IP is reserved. But in AWS, 5 IP addresses are reserved. I would highly recommend you to take a look at any subnet calculator that is available online for you to create your subnets. So the way that you approach this is you take a very big network IP address, and then you think about how many hosts you would like to allocate in each and every network, based on which you go ahead and create your subnets, having enough subnets as part of buffer that you can create at a later point of time, if at all you want to extend your network into more subnets. Okay. So I hope you got a small idea into subnetting and how do you do it. In the next section of, or the next video of the Networking 101 lecture, we will take a look at some of the other concepts such as private subnet, public subnet, and so on. So thank you for listening to this lecture. Have a great day, have fun, and I'll see you in the next one.